Okay, this is lesson 2.3 that talks about deductive reasoning. So we've already talked about inductive reasoning, but you may not have known that's what we were talking about. So it was earlier when we were making, we were going to StatEdit and typing in those patterns or looking at patterns in the picture and coming up with equations and finding like the 55th term. So inductive reasoning is based on a pattern. It's where you look at specific examples, and from that you come up with a general rule. So, for example, if you notice that every day or every Wednesday in the cafeteria they serve chicken, and you decided, based on each Wednesday's specific example, you decided to make a general rule that Wednesday we always have chicken. That would be inductive reasoning. However, because that's not necessarily always true, the conjectures you make with inductive reasoning are not always valid. Now, a lot of times they're valid, but not always. Okay, so deductive reasoning is what we're starting today. This is a little bit more reliable. This is based on rules, rules, definitions, theorems, postulates, formulas, anything like that. Anything that you're told is a definite rule. Like if I give you the lunch menu and you see that every Wednesday it is chicken, and your conjecture is that we're going to have chicken on Wednesday, that's a rule that was given to you. So that would be deductive reasoning. You didn't base it on a pattern. Now this takes a general rule and applies it to a specific example. So if I give you the rule of Pythagorean theorem, you can apply that to any example of a right triangle that I give you. So the rule would be Pythagorean theorem, and the example would be just one triangle that you're using it on. Now, because this is based on facts and rules, I didn't put facts. Sorry, that's my favorite one. Facts. It's based on facts and rules and definitions. These are always valid. Now, conjecture might be a new word for you. It's kind of hard to explain because I always say draw a conclusion, but because we use conclusion and hypothesis with conditional statements, we can't really use that on this. But it's basically just making a statement based on what you see. So you probably could think of it like drawing a conclusion, but we say conjecture just to not confuse the two words. Okay, I know it's a lot of reading, but this isn't too difficult. You're going to discuss each of the following and determine if it's inductive, which means it's based on a pattern, or deductive, meaning it's based on a rule or a fact. Okay, so you observe for the last 5 to 6 weeks that the school cafeteria has served chicken on Thursdays. Look, that was the example I gave, except I said Wednesday. Since tomorrow is Thursday, you conclude the cafeteria will serve chicken. So, because you base that on the pattern, the last 5 to 6 weeks they've had chicken on Thursdays, that is inductive reasoning. Again, if it was deductive, it would be like based on the menu that's given to you. Since your lowest grade in history on any assignment or test is a 92, you conclude that your average grade in history class is a 92 or above. That is deductive reasoning. That's based on a fact. You guys know how to average numbers, hopefully. If I add 92 and 100 and 95, if I don't add anything lower than 92, when I divide it to average it, there's no way it could be lower than 92. That's based on a rule of how you find averages. One of your car's tires is inflated to 40 psi. Since the side of the tire rates the maximum tire pressure at 35 psi, you conclude that the tire is overinflated. That's based on a rule that you read on the side of the tire. So that is deductive reasoning. Now, a great example of inductive reasoning would be that if you inflated a tire to 40 psi and it exploded, and then you did another tire to 40 psi and it exploded, and then you thought, maybe this is too much. That would be inductive. That was based on a pattern of them exploding in your face. So, because it's based on the rule written on the side of the tire, it's deductive. So I'd kind of like it for you to pause this and read these and see if you can try them before I go over them. So Bob, the big bad boxer, has won his last 11 matches in less than 5 rounds. You conclude he will win his next match in less than 5 rounds. That is inductive reasoning because it's based on a pattern, based on the last 11 matches. Fred and Amanda both solve the same algebra problem, and Fred's answer is 2.5 while Amanda's answer is 5/2. You conclude that they are both correct. Now, I do think this one's kind of tricky because my first thought is, are they really correct? But I think we're supposed to assume that one of these is right so you can make the conclusion that they're both right. So that's just based on the rule that 2.5 is the same as 5 divided by 2. So since that's just a math rule, that's deductive. But I do see how that one's confusing because I think the first time I read it, I thought, well, they're both getting the same answer, so we think they're right because it's a pattern. But I think you're just supposed to assume that it's right, and you're just saying that these are the same. And that is based on a rule. Okay, so when we have deductive reasoning, so we've already done inductive, now we're doing deductive. We have 2 laws that we're going to learn. The first one is the law of detachment. Remember, P and Q are the hypothesis and conclusion. So if P then Q is a true statement, and we know P is true, then we know that Q is true. That's just a law. So if the hypothesis is true, the conclusion must be true. So let's write a sentence here. If you wear jeans on Friday, then you get candy. Wouldn't that be nice? Okay, so the hypothesis is you wear jeans on Friday. The conclusion is you get candy. So what this is saying is, first of all, this has to be a true statement. So let's pretend like we're doing some fun activity where if you wear jeans, I give you candy. So we know this is true. And then we know that P is true. So we know that you definitely wore jeans on Friday. So what the law of detachment says is that you can conclude from that you definitely got candy. Because the statement's true, this happened, so this has to happen. So in the World Series, if a team wins 4 games, then the team wins the series. So here is our conditional statement. So let me figure this out. A team wins 4 games. That's a hypothesis. The conclusion is the team wins the series. So in order for us to use the law of detachment, we have to know that this first part, the hypothesis, happens. So this says the Red Sox won 4 games in the 2004 World Series. So that says that this did happen. So from that, the conjecture says the Red Sox won the 2004 World Series. Which is that part? Well, since this part happened, this part definitely happened, so that is a valid conjecture. You could also put true, if I'm sure you are more comfortable with that. Okay, so this says if the side lengths of a triangle are 5, 12, and 13, then the area of the triangle is 30. So this is the hypothesis. This has to happen. And if it does, then we know that this part happens. Oh, I'm just now reading the directions. I'm sorry, I've messed that up. It doesn't really matter, but I was supposed to underline the hypothesis once and the conclusion twice, so I should have underlined that twice. So let me try this one again. So the side lengths of a triangle are 5, 12, and 13. Then the area of the triangle is 30 square centimeters. Then it tells us that the area of this specific triangle is 30 square centimeters. So, did it say that the hypothesis happened? Did it tell us we have a triangle with these side lengths? No, it said that this happened. Now, the law of detachment says nothing about if Q happens, you can say this is true. So, if it says the side lengths are 5, 12, and 13, this is not valid. You cannot say that just because the area is 30 that those are the side lengths. The hypothesis has to be the one that you know happens. So, for example, if I had this triangle with a base of 15 and height of 4, it's not even a right triangle with sides of 5, 12, and 13, then that equals 30. So it's very certain that it's not valid. All right, chain law is a bunch of if-then statements put together. So it's like if P, then Q. If Q, then R. It makes a chain. So it's still kind of like law of detachment. The first thing still has to happen. But on chain law, you can basically take out the middle and your conjecture is a if-then statement. So if P happens, then Q happens. If Q happens, then R happens. And that means that if P happens, the very first thing, then the very last thing happens. Now this is just a two-chain conditional statement, but you can have as many as you want, and as long as the first thing happens, you know the very last thing happens, because it just creates a chain effect of law of detachment. This happens, so this happens. This happens, so this happens. But the conclusion of one has to become the next hypothesis. Like these have to be the same. So, if a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. So that's a chain law. It has two statements. So this is P, it's a kite. It's a quadrilateral is Q. It's a quadrilateral still Q, and this is R. I'm just using those letters from this. So basically you just take out the middle part, and if the first thing happens, the last thing happens. So for this to be valid, we would have the first hypothesis and the last conclusion. So it'd have to be if a figure is a kite, then it is a polygon. Is that what this says? If a figure is a kite, then it is a polygon. Yes, so that is valid. And there's a lot of different names for chain law. This is one of them. That's why it says it in the directions. But I won't ever put that. I'll always put chain law on your tests. Okay, if a number is divisible by 2, then it is even. If a number is even, then it is an integer. So the only valid conclusion we could make is if the very first thing happens, the very last thing happens. So if a number is divisible by 2, then it is an integer. Is that what this says? If a number is an integer, then it is divisible by 2. No. It had to be this part first, so this is not valid. Now this will have both law of detachment and chain law. So if a polygon is a triangle, then it has 3 sides. If a polygon has 3 sides, then it is not a quadrilateral. So from that and from chain law, we can take out the middle and say if the first thing happens, the last thing happens. So our new statement is if a polygon is a triangle, then it is not a quadrilateral. And this says polygon P is a triangle. So it's saying that this happened for polygon P. So from law of detachment, we know if this happened, this happened. So our conclusion or conjecture could be polygon P is not a quadrilateral. And that's it.